So for our first question, we have to find the zeros of f of x equals 2x cubed minus 11x squared plus 10x plus 8. And use the zeros to write f of x in factored form. So there's our function. We know we have to find a p, a q, and a p over q, so let's start. P. The candidates for p are all the factors of 8, which are 1, 2, 4, and 8. The candidates for q are all the factors of 2, which are 1 and 2. Now for p over q, our candidates are plus or minus, and when q is 1, we'll have a 1, 2, 4, and 8. When q is 2, we'll have a 1/2, and all the other quotients are covered because 2 over 2 is 1, 4 over 2 is 2, and 8 over 2 is 4. And finally, we have to have a starting point. Let's see, I'll put our coefficients down in descending order relative to the exponents on the variables. And we have a 10 and an 8. 8. And we've got to start someplace, so evaluating all these p over q's using the factor theorem, when we evaluate f for 2, we get a 0. So let's start there, because we know we're going to get a 0. And we'll bring down the 2, multiply by 2, we get 4, add these up, we get negative 7, multiply by 2, we get negative 14, add them up, we get negative 4, multiply by 2, we get negative 8, and there's the 0 we knew we were going to get. So this tells us that in factored form, f of x equals x minus 2 times, and this is 2x squared minus 7x minus 4. So it turns out this factor is also this quadratic. So x minus 2 times 2x and x minus 4 and 1 plus 1. So now there's our f of x in factored form. We were asked to do that, and the zeros are at x equals, well, what'll take that to 0? Negative 1/2. Then we have a 0 at 2 and another 0 at 4, and I would say we're done. Well, for number 2, we have to use the intermediate value theorem to show that f of x, which equals x cubed plus 5x squared plus x minus 7, has 0 on negative 2, negative 1. Well, to use the intermediate value theorem, f has to be continuous on whatever closed interval we're given. Well, f of x is a polynomial, so f of x is continuous everywhere. So f of x is continuous on the closed interval negative 2, negative 1. Then we have to evaluate the endpoints. So f of negative 2 equals 3, which is greater than 0. And f of negative 1 equals negative 4, which is less than 0. So now let's graph this thing. So let's see. And here we are. I'll call this negative 1 and call this negative 2. And at negative 2 we're at 1, 2, 3. So negative 2, 3. And at negative 1 we're at negative 4. Negative 1, 4. Now, f is continuous, so if it's continuous, will you agree if we were to draw all the points on this interval, then we would have a continuous or a complete set of values all the way through this interval and landing right there at negative 1, 4. So, therefore, there's going to be a 0 someplace. And we don't care where, we just know there's going to be a 0 on this interval. So by the intermediate value theorem, f has a 0 on the 0, spell that correctly, 0 on the closed interval negative 2, negative 1, and here's why. One more time. It's continuous on that interval. F1 of the, for f of negative 2 we get a 3, which is above the x-axis. For f of negative 1 we get a negative 4. Let me rewrite that. Negative 4, which is below the x-axis. So since it's continuous, it has f, if we were to graph every point on this interval, f would have to intersect the x-axis somewhere, giving us a 0 at that point, and we're done.